name is Jacob George, and I'm assistant professor in the Department of Electrical and Computer Engineering, and I also have a joint appointment in physical medicine and rehabilitation. So a lot of my research is focused on medical and healthcare technology, and particularly kind of using bio-inspired artificial intelligence and brain-machine interfaces to enhance human function. We have a really diverse group consisting of graduate students, undergraduate students, research associates. We're really collaborative and we work with people from all sorts of different backgrounds. So NeuroRobotics is the lab that we're in. It's Utah NeuroRobotics. And it's a really interdisciplinary area. So we kind of are at the intersection of assistive and rehabilitative robotics, where we focus on upper limb orthotics and prosthetic hands. We also use sensory motor neural engineering. So these are those brain-computer interfaces. We do both invasive and non-invasive technologies. And then we use artificial intelligence, particularly bio-inspired artificial intelligence, as the link between these rehabilitative robotics and the human nervous system. So I'll show this video as one example. Hopefully the audio comes through well and you guys can see everything pretty smoothly.
I can actually not see the screen.
Oh, yeah. Okay, let me.
Yeah. We see a message that says you started sharing your screen, but oh, there it is. We can see it now.
How's that? Okay, great. So this is our team, lots of fun people, very diverse group. This is kind of an overview of the research we're working on, kind of intersection of these different things. And then, just to give some fun examples, I picked a few different, projects. We have a ton of different projects. I'd encourage you to check out our webpage, but I'll just kind of give a quick overview of a few different ones. So this project was picked up by a bunch of different news outlets, and I'm happy to say that we now have FDA approval for this device, and we're moving forward with the take-home system. And so that'll be an exciting new research direction going on. As put by one of our participants, early on, they said, soon it will be just like Luke Skywalker, and then everyone will want one. And so that's another direction we're moving in, is to make, every single one of us be, Jedi masters, where we can control different technologies with our thoughts. So we are now working on developing a smart watch system that can record electrical activity from your arm muscles and nerves and use that to control smart devices, leveraging a lot of AI and different robotics platforms. And who would this technology really benefit? It's actually probably not the everyday person, but it's the people in the hospital that we work with. So we work very closely with people with neuromuscular disabilities like stroke, spinal cord injury, and amputation. And this type of technology would enable them to interact with their environment in a more seamless way. And so another fun project that we're working on that I'll just kind of use as an example is for adaptive sports for people with spinal cord injury. So in this case, the way that people with spinal cord injury typically move around is they have to blow, if they're paralyzed from the neck down, they have to blow into a straw, and blowing into it actually would steer their wheelchair to the left, and sucking into it would steer their wheelchair to the right. And that same kind of thing happens with an adaptive system like this. And so the University of Utah has awesome mountains that are nearby, and we have this awesome program to get people with disabilities back onto the slopes or back onto the mountain where they're doing extracurricular activities and things like that. And in this particular case, the technology that's there doesn't work great. And so we're hoping to use brain-computer interfaces to allow them to more dexterously and intuitively interact with the world. And so we got to test this recently with a participant, and this was kind of their interaction and their experience with it.
I'm more excited about this than honestly anything that's happened since I broke my neck. Using a sip and puff to ski was amazing, but with these controls, I could go back to skiing what I used to ski, like difficult, fine controls. Right now we just have like left turn, right turn, wedge, unwedge. I mean, 10 degrees of freedom. I could just imagine.
So, this project was really impactful for this particular individual, and we're hoping to expand this and make this into, commercial devices that people can use regularly in their activities of daily living. So, normal technology, they can control basically 2 different movements, and we're moving that up towards 10 movements controlled entirely by thought. So, with that, I'll just say we have a variety of different openings in our lab. We're looking to recruit people for a bunch of different projects. This is just a few that I picked out that I thought are particularly fun and interesting, but we have a lot more going on. So I'd encourage you to check out our website. That's neurorobotics.ece.utah.edu, and check out the different programs we have, as well as some of the media coverage and the articles we're doing, as well as the people and alumni that are coming from the lab. And if you have any questions, feel free to reach out to me by email at the bottom of the screen, jacob.george@utah.edu. I won't be able to stick around for the Q&A. So if you have questions, feel free to reach out with me. I'm happy to schedule a time to meet with you all. And thanks for listening.